Today we shall discuss physics problem 35. Statement you can see on the board. A load of large certain mass mk kilogram is to be lifted to a height h using a rope whose breaking tension is given as T newtons. That is more than T newton. If it gets into that tension, more than T newton means it will break. So within that limited tension, the same kilogram has to be lifted to a height h. Not just lifting, it should be lifted from rest to rest. That is, starting at rest and then it should stop. At that height it must stop with the maximum tension available. So what is the minimum time in which this can be done? That is the question under the given conditions. And the tension T newton, breaking tension, is more than mg. That has to be the case because otherwise the weight cannot be lifted up. So let us see the procedure involved. First it has to be lifted with the maximum acceleration that is possible with these conditions. Maximum acceleration. At that maximum acceleration, it should be lifted to certain height, and by the time it will reach a velocity v. Starting from rest, it will reach a velocity v maximum, which I am denoting as v. Then, at that instant, we stop the force applied so that the tension will become zero in the rope and the body will move, that load will move with under gravity with minus g retardation g. It will go and at the required height h, it will just stop. So somebody here can catch it. So when it reaches this height, it will be at rest, starting from rest and reaching the height at rest. So the procedure is maximum acceleration. First we have to work out. A maximum is given by Newton's equation. T maximum is denoted as T. A maximum I am denoting as A only. A maximum equal to A. So T maximum is T, positive force, minus mg. Mg is the load weight, mg. So T minus mg is equal to m times A maximum A, which I am denoting as A. So you get that, from which we can get A equal to T by m minus g. T is greater than mg means so this will be positive. Minus g. This will be a positive acceleration. And also we know A plus g will be T by m. Both this expression for A plus g equal to T by m, both we have to use later. Then raise the load at this acceleration till it reaches the velocity v maximum, which is denoted as v. Then at that height you stop the force, so that will go under gravity retardation, and at the required height it will stop. So that's the idea. Raise the load at this acceleration. Raise the load at this acceleration. At this acceleration till it reaches v maximum, velocity maximum, v maximum, which I am denoting as v. reaches, then we stop the force, stop the force, so that the load rises under retardation. Load rises under retardation G. Retardation, when we call, you can just put it as G. Minus G is not necessary. When you call it acceleration, you put minus G. So retardation G till it reaches height h. And stops. So at that stopping point, velocity 0, somebody has to catch it at that height. Here, somebody has to catch the item. So now let us see how to proceed. We have to draw a travel graph for this, because question is based on travel graph also. So let us see. I will delete this. I will clear the board before I draw the graph. Okay. So what I said is represented by the velocity time graph. We are representing it with a graph. Velocity vertical axis and time. Initial acceleration A. Then retardation G. Minus need not be, because this negative slope means G will be minus. So initial acceleration, it reaches a maximum velocity V. For which, let us say, the time involved is T1. After force is stopped, it will go under retardation G. Let the time be T2. So T1 by plus T2 is the total time T, which is what we want to minimize. The time will be minimum if this process is carried out. Time will be minimum. Okay. So we know the slope gives the acceleration. So V by T1 is A. V by T1 is equal to A. Then, which implies T1 is equal to V by A. Likewise, T2 is equal to V by G. So the total time is given by total time T equal to T1 plus T2, which is equal to V by A plus V by G. It implies, okay, you can write it as V A plus G by AG. This is equal to T. So V equal to V by into A plus G by T is equal to T. AG equal T. Now, that is, we are using the slope for the velocity time graph is acceleration. That concept we are using. Then, area under the graph is equal to the displacement, which means of base is T, height is the maximum velocity V. Of TV is equal to height h, the reason height h, area of the graph, which implies V is equal to 2h. V implies V equal to 2h by T. So here also V is available. So just substitute B equal to 2h by t in the first equation, which gives us 2h by t times a plus g by ag is equal to t. So t square is equal to, which implies t square is equal to 2h a plus g by ag. That gives us the minimum time. This is square root of this will be the minimum time we want, but since a is not a given quantity, we substitute for a, which implies t square is equal to 2h by g to 1 by a. 1 by a is available as 1 by t by m minus g times a plus g is already we know is t by m. So this t is tension, small t is the time. So this implies t, what we want, the minimum time, is given by 2ht by t minus mg into g square root of the whole thing. This is the answer that we are looking for. Let me rewrite the answer. Our answer, final answer is T minimum is equal to, required T minimum is equal to T minimum is equal to 2ht by T minus mg into g square root of the whole thing. That is the minimum time in terms of the given tension. Given maximum tension and the height involved, in terms of that we get this answer. So I think you can follow we will make use of this result in our next problem also. So you take note of the steps.